In the span of a single century, the world celebrated the discovery of an early human ancestor in England, the creation of molecular-scale transistors, and the successful cloning of human embryos. All three breakthroughs commanded global headlines and promised to rewrite the textbooks. Eventually, all three would crumble to dust, exposed as complete fabrications. We are taught to view the scientific method as an impenetrable fortress of truth. It is designed to be a mechanical filter that strips away human emotion, leaving only hard data and relentless skepticism. But looking at the raw, chaotic reality of how data is actually gathered in the field, a question emerges. If this system is so rigorous, how do blatant fakes manage to bypass the world's smartest minds? The answer is surprisingly simple. The most successful scientific hoaxes in history do not rely on flawless, undetectable mastercrafts of forgery. Instead, these fabrications succeed by tailoring their claims to the specific professional desires and deep-seated biases of the scientific community. The primary vulnerability of the scientific method remains the human mind, which can be far more fallible than any laboratory instrument. The first major vulnerability is confirmation bias. This is the psychological tendency to readily accept highly flawed data if it perfectly aligns with what we already believe to be true. In 1912, researchers announced the discovery of the Piltdown Man in a gravel pit in Sussex, England. It was hailed as the evolutionary missing link between apes and early humans, and it fooled leading experts for 40 years. The scientific establishment accepted the Piltdown Man almost immediately because it gave British scientists a narrative they desperately wanted. It offered physical proof that early human evolution was centered in Europe and that a large, intelligent brain developed long before the rest of the human body. The reality of the forgery was shockingly crude. The artifact was nothing more than a medieval human skull paired with the jaw of a recently deceased orangutan. The bones had been clumsily stained with iron solution to look ancient, and the teeth were literally filed down by hand to mimic human wear patterns. For decades, experts looked directly at these obvious physical anomalies and ignored them. To question the authenticity of the fossil would mean questioning their own favored evolutionary theories. The scientific method is easily blinded when a lie tells the establishment exactly what it wants to hear. The second vulnerability is the halo effect. This is a cognitive bias where the prestigious reputation of a specific scientist or university prevents others from thoroughly questioning their work. This bias perfectly exploits a massive public misunderstanding of peer review. When people hear that a paper is peer-reviewed, they often picture a forensic, microscopic investigation into the author's honesty. But peer review is actually a much narrower mechanism. Peer review only checks a paper's internal logical consistency, assuming the underlying data was gathered honestly. This filter becomes compromised when a paper arrives carrying an elite institutional logo. Reviewers see the prestige, assume the methodology is reliable, and voluntarily lower their guard. In highly specialized, hyper-competitive fields, blind trust in a famous name dangerously replaces rigorous trust in the actual data. Modern science has moved far beyond digging in the dirt. It is dauntingly complex, expensive, and hyper-competitive, which introduces the third blind spot: systemic pressure. Academia operates on a strict publish or perish culture. A scientist's lab funding, their career trajectory, and their chance at tenure rely entirely on their ability to publish a constant stream of discoveries. This chart shows how the scientific funding ecosystem distributes its rewards. It heavily incentivizes positive results, meaning you found something new. Meanwhile, it allocates almost zero funding or publication space to null results, which is the vital work of proving a hypothesis wrong. Over time, this intense pressure erodes ethical boundaries. Scientists aren't out there carving fake fossils anymore. They are sitting at computers, subtly manipulating spreadsheets and cropping digital images to ensure their data yields a publishable outcome. The very system designed to uncover objective truth unintentionally acts as a breeding ground that incentivizes compelling fiction. Yet, despite these massive psychological and systemic blind spots, every great scientific hoax eventually collapses. They collapse because of the ultimate safeguard of the scientific method: reproducibility. Reproducibility is the requirement that an experiment must yield the same results when performed by an independent researcher. A charismatic scientist can fake a dataset and coast through peer review on the strength of their reputation, but they cannot prevent independent laboratories across the world from taking their exact methodology, trying to replicate it, and failing. These historical embarrassments are not reasons to abandon science. They are vital stress tests that expose the human ego embedded within the research process. Scientific literacy requires looking past the initial excitement of a breakthrough headline to ask how the data was actually gathered. The system operates as a messy, human, but ultimately self-correcting machine that depends on persistent skepticism to produce objective truth.